then it gets complicated when we don't have any of them as 0. But if you understood everything so far, then it's not that complicated because it's the same thing, just with another variable, right? It's exactly the same thing, all right? So we have a system and going from one state to the other, and my delta U has to be equal to Q and work. Okay, so let's assume that my delta U is increasing. So I have my state 1 here, and I'm going into my state 2 here. Okay, for that to happen, there are a couple of options. What are the options that I have for this to happen? Well, let's actually put them all down here. Let's put them all down here. 1, 2, 3. Okay, I know my internal energy is increasing. What can be happening? Well, I can be getting heat, and put Q as heat, and work. And both are contributing for this to happen. What is the other option? Well, I can be getting some heat in, yet there is some work going out. That's the second option. Or, last but not least, I have some heat going away from my system, yet I have work being done to my system. Those are the three options, right? Only options. If there are heaps of different works being done, you're just going to sum them all up and see what's the resulting, right? Is the resulting one mean something being done to my system or something being done by my system, right? Is it done to my system or is it done by my system? Okay, those are only three options if my internal energy is increasing. And you can use this to your advantage when you're solving problems. And so you take a problem, you see what's happening with the delta U, and then therefore, if it's increasing, then these are the only possible combinations. And then it might be obvious, yet let's write it down, that the inverse is also true, right? So we can inverse the possibilities here, and we can say, oh, okay, if I want to do it this way, I think I'm just going to write it from scratch. My state number 1 is greater than my state number 2, right? Internal energy-wise. So for this to happen, well, only 3 possibilities, right? What's the first possibility? Well, the first possibility is that I'm both losing heat, both have heat going away from my system, and my system is doing some work. It's expanding, right? My system is expanding, doing some work. Second option, well, I'm losing some heat, heat's leaving my system, but I'm giving some work to my system. Well, I can be sure, right? And I should have said that probably in the previous case. I can be sure that the heat being done is greater than, the heat leaving the system is greater than the work being done to my system. Because the heat needs to account for the work that's being done to my system plus the change in delta U, right? What's the last option? Well, the last option is I still have heat going in, yet my system is expanding so much that it's using up the energy that is being given by the heat, plus it's consuming some energy from the delta U, and it's going from state 1 to state 2. Okay, those are my options. Only options, right? So in this case here, the work is absolutely, definitely greater than the heat leaving the system, right? Because it needs to account for the heat leaving the system plus the change in internal energy there. Okay, and I'm going to repeat this with all the other cases. Like instead of looking at internal energy, we can look at heat, right? What if I'm sure that heat is leaving my system? What if I'm sure that my system is expanding? What if I'm sure if my system is compressing? That's always going to be the case, right? So if you write these guys down and you think about these possibilities, it has to be one of them. And once you figure out which one it is, it's also going to be rinse and repeat, and you'll be able to understand and solve these problems in a much easier way. Okay, so let's look at heat. What happens with heat? Okay, heat can be leaving my system. And let's go ahead and draw this system 3 times. Okay, and heat is leaving my system. Heat is leaving my system. Okay, so if heat is leaving my system, there are a couple of options, right? Either my internal energy will decrease, right? So my external energy is going to go from state 1 to state 2 and decrease. Okay, which will compensate for this heat leaving my system. or my work is going to change the volume, right? So the other option is work to be able to take care of this. Think about it. We have energy leaving my system, and it's a combination of things, right? Actually, we should say the combination of things. It can be work going in, like so. It can be energy going down, energy leaving the system, and then work going away. So in this case, what's happening? Well, the heat that's leaving, it's taking away the difference in energy here and this guy that's being given to it. What about over here? Well, same thing. The heat that's leaving the system, all right, is taking away all this internal energy, plus there's some extra energy that's leaving in the form of work. Another option. State 1, state 2. My internal energy is actually increasing. Okay, but I know that I have some heat leaving my system. Okay, so that means that there's only one option, right? For the heat to be able to leave my system, yet this guy be increasing internal energy, then I need to have work being done to my system. And I can be absolutely sure that this is compressing my system, right? What about if we had system 1, state 1, sorry, state 2, it's increasing. I'm sure that heat is leaving. Okay, that's what the premise of this thing. And I also have work leaving. Well, that's impossible, right? Because for this guy to be able to increase internal energy, then I need one of these two guys to be going in. So this guy here cannot happen, right? That's impossible. It cannot happen, right? So when I have some heat leaving my system, these are the three options that I have. I can have the heat that's leaving my system be due to the change in internal energy, because it's decreasing internal energy, plus the heat be due to the energy being given by my system, that is, when work is done to my system. The other option is that the heat leaving the system is due to the internal energy, yet at the same time, I also have some work being done by the system due to its internal energy. Right? And the last option is this one that we discussed already. We have heat leaving the system, right? And in spite of the heat leaving the system, we have an increase in internal energy. So therefore, the work that's being done to my system is being used up to be able to increase its internal energy. That is, it's compressing my system, the volume is decreasing, and the rest of the energy is leaving in the form of heat. Okay? And then we can do the same thing here if my heat is going into my system. Right? So like so. So again, let's read some repeats. This. Let's see what's possible, what's not possible. At the bottom here. Okay, so now I'm saying that heat is definitely going into my system. All right, so heat is going into my system now. Cool. Heat is going into my system, and work is being done to my system, yet my internal energy is decreasing. Not possible, right? Impossible. If these two guys are going into my system, then internal energy needs to increase. Next option, let me just make all these going in so that it makes more sense. Going in, and then here, going in. Okay? Second option, I have heat going into my system, and then the heat that's going into my system is all leaving in the form of work being done by my system. So note that internal energy is decreasing, heat is being given to my system, so therefore the combination of these two energies all need to be going in the form of work. So I can be sure that my system is expanding in this case here, right? Its volume definitely needs to be greater than initial volume. Volume 2 definitely needs to be greater than volume 1, because all the energy that's being gathered by the change in internal energy, plus all the energy being gathered by the heat going into my system, is being used up as work being done by my system. All right? And then the other one here is we have our energy going into our system, our heat going into our system, and then some of this energy is being used up to be able to increase my internal energy, but not all of it, right? If I didn't have the work here, then let's say that I would only go up to here, right? But then we also have that work going in, and therefore I can reach the state 2 that I said in the beginning. Okay, so let's go back to the original drawing. There you go. Okay, so the internal energy, the heat is giving internal energy, is increasing my internal energy by some amount, and then we also have work being done to our system that's going to give us the extra boost that we need to arrive at state 2. That's option number 3. And then option number 4, we have heat being given to our system, and our internal energy is increasing, okay? But we're also doing some work. Our system is also doing some work, so there's also some work being done by our system. Okay, so what does this mean? Well, the heat, all the heat here needs to be sufficient to allow for this internal energy to increase, plus to allow for some expansion of my system, right? Because I'm using up this energy to expand. Okay, those are the possibilities. And then obviously this is the same thing if we turn around and look at work, right? What's happening with the work? Well, if work's going in, it either needs to be captured in the form of internal energy or heat. If we're using up work, then we're either doing that at the expense of internal energy or at the expense of heat. Those are all the possibilities within a first law system. And if there's anything that isn't clear, then just hit me up and we can talk more about this. But I thought this video might be useful for you if you're learning this and you're confused about when do I sum up the work, when do I subtract heat, when do I consider the delta U. It's always going to be one of these possibilities, right? And the last thing I want to say in this video is, if you think about work as pressure dV, as we go from V1 to V2, whenever we are expanding, so when we're expanding, my system is expanding, then the volume 2 will be greater than volume 1, right? So therefore, the work will be P V2 minus V1, which is positive, right? So just write positive. If it's being compressed, then my volume 1 will be greater than my volume 2, right? So therefore, this becomes P of V2 minus V1, yet this guy here is greater than this guy here, so this whole number is going to be negative, so this becomes a negative number. So when I solve these problems, this is the kind of convention that I use, right? If my system is expanding, if the fluid is increasing in volume, and therefore that's going to be positive work. If it's being compressed, then it's going to be negative work. This doesn't matter so much as long as you explain your final answer, right? So if you say work is being done to my system or by my system. Oops, let's do this in yellow. Okay, if it's by my system, well, it's using up energy, needs energy, needs to use energy, right? If it's being done to my system, well, then it gains some energy, right? Gains energy. Okay, I think having this framework is going to be useful for you if you generally confuse these things. So if you don't like using the positives or negatives, you'll know that in this channel, whenever I do problems, I'm always gonna say the first law is Q plus or minus work, because I don't know where you are in the world, and this may be different for you. But if you have this framework in mind, right, the idea that energy, if it's being done by your system, it requires some energy to be done. It needs to, quote unquote, consume some energy. And if it's being done to your system, then you're, quote unquote, gaining energy. I think that's easier for you to have in mind to be able to solve the problems. Right? Other than that, if you have any other questions, just leave them down below in the comment section. I really hope this helped you out. If it did, consider maybe liking this video, and we'll talk soon.